Anyway, about our UNIVAC. We acquired a UNIVAC 1219B, military version of a corporate 418-2 several years ago. Never in my wildest dreams did I imagine it would run. And two of our members, Bill here and a man named Dwayne, who couldn't make it this weekend, said, we worked on this in our Navy days, let us at it. And we did, and now it basically runs. Blow my mind. As far as I know, there's maybe 4 or 5 left in existence, right?
I don't know.
Yeah, there was another one we knew about at a government location, and one day the manuals magically disappeared and magically showed up here. We like science, but it was magic. Anyway, you didn't come to hear me talk. I'll give the floor to Bill. Keynote speech about the restoration of our UNIVAC mainframe. Bill Dromgoole.
All right, well, first of all, we got this computer in 2010 from Johns Hopkins University when they were closing down one of their buildings. And they gave us 2 computers, 2 1540 tape drives, and 4 I/O consoles. So that, we called them a Mark 77. They call them a 1532 or an OJ. Just different names. The government has a way of naming everything. So anyway, the question would be, why does Johns Hopkins have this? Why would they have a military computer? Well, it turns out Johns Hopkins, the Applied Physics Lab, was started in 1942 during the war. And what they were doing was they were developing a fuse, was a proximity fuse for a 5-inch gun. And it's really amazing the things that they've accomplished. They made basically a small radar with 4 tubes that they could put inside a shell and fire it. It was 20,000 Gs. Can you imagine that? Anyway, and it worked. And then after that, they started this project called Bumblebee. Now, Bumblebee was a joke based on the idea that a bumblebee can't fly. And they were developing missiles. They were trying to develop this Tails missile, which was the first supersonic ramjet missile. And they also were working on a Terrier missile and the Tartar missile at the same time. They developed them for the Navy. They do a lot of work, development work for the Navy. Now, they don't make the missiles, or they don't make the computers. They just do like the system integration. Like they would put out a spec, say, we need this kind of a computer to solve this fire control problem. And then they would get like UNIVAC or somebody to make it, and and they would write all the software for it. And we're at here. So anyway, so eventually they got the missiles onto ships. And the first ship to have one was the USS Boston, and that was back in 68, the first ones. Now, they had these all the way up until like say 70, but all these different size ships had different size missiles. One missile might be a real long range, one's a short range, and one's a medium range. The problem was that they all use analog computers. And the Navy was deciding that they would like to switch to digital computers. And the real problem was that the admirals and everything in the Navy didn't really want digital computers. They thought that they were taking away their command or something. So they worked on, they got this system called NTDS, which is Naval Tactical Data System. Now what that was is that's basically a way of using computers to control aircraft, to see any target you have, surface targets from the shipboard radars, etc. And they would use these to tell the missiles where to fire, where to aim at. Well, of course, they had to build all these analog to digital converters to convert everything into a format that the missile systems could use. So, anyway, it was about 1965. There was, I think, 10 ships in the Navy that had NTDS on them. And they were finally starting to agree that this is a good idea. And then the big problem was that the attack scenarios were changing. They were worried about raids of a lot of targets, like Pearl Harbor, where they send in like 100 planes at one target. There's no way that the systems on a ship could keep track of it all. So again, that was the main reason for NTDS. Anyway, NTDS, eventually they wanted to go to digital computers for the fire control systems as well. The problem was that anytime some new threat came out, you had to redesign the computer. And the analog computers were all hardwired. They were all like gears and synchros and resolvers and all these mechanical apparatus. And it took a long time to do it. It would take you like 2 years maybe to put a change in for some new threat, and that wasn't really fast enough. Where with the digital computer, they would be able to put in, they just change the program. I mean, it's still more than that because you had to always go back to the testing, et cetera. Anyways, let me see where I'm at here. So this is a drawing of a 1972 era fire control system. And you can see it's got 3 search radars. There's 2 guided missile fire control radars at the other end, the missile launcher. And right, well, you can see right above the word engagement, you see the GMFCS computers. That's the computers we have in our lab right now. And right next to it is the Mark 75 SDC. So what they would do is targets would be found by the search radar basically would display the targets on these consoles, just like you see on TV, the weather radar going around. But they'd have people sitting there and they would like put a little, they had like a bolt, what do you call it, a ball tab, like they call it, I can't remember what you call it, a trackball. And they would move a symbol on the scope over a target and they'd click it and that would enter it into the computer. Then maybe the next time the target came around, they would enter it again. And after like 3 times, the computer would keep track of the target and keep updating it without them doing. And of course, they still had to keep updating it, but they only had to update their smaller changes. And then they would send the information over to this WDS Mark 11 console, and that would go down to our computers and the STC, and that would control where the missiles pointed, where the radars pointed, et cetera. This is just another picture of the equipment. Now those consoles, they're pretty big. They're not like a ADM3 or anything. Those are like $100,000 a piece. And they're showing 3 there, but in reality, there's like 20 at 2 different levels of the ship. And of the 2 radars, the search radar, the top one, the 48, that's a 3-dimensional search radar, and the others are just 2-dimensional. And the WDS system basically just sends the information down to us. In future revisions, though, they got rid of that weapons direction. They made that part of NTDS, and they put in some Yuck 20 computers to do the function that previously did. Again, just more information. That GFCS computer, the gunfire control system computer, is a mechanical machine. That was kind of interesting because it had drawers that you could pull in and out. But in the back it had gears runners. They got like shafts with gears on them. And as you pulled the drawer in, or plugged it in, it would engage a gear. And that would be like kind of like the clock of the mechanical computer. And it's pretty interesting, really. This would be a ship that had our computer on it. Now, just for reference, that big top square antenna, that was the 48 3-dimensional radar. These 2 domes over here on the side That's the 55 radar. And of course, you see the missiles on the missile system. This ship had 4 55s that had missiles fore and aft. And right here, you see this little section here. That's a anti-ship cruise missile. That's a, I can't remember, Harpoon is what they call that. That's a Harry Yarnell, that ship.
What year is that ship?
Well, they're all decommissioned now. This would be, I'm going to say 75 in that range, 75 to 85. This is USS Mahan, and those, I'm just showing this picture to show you how big those dishes are. Those are the 250, those are the ones that control the missile radar. Now, it turns out that Johns Hopkins, because they were the design agent, they had that radar physically at their site. They had a missile launcher, they had the computers, they had consoles, they had everything. Because they did all the development work for the Navy, whenever a new program came out, or that type of thing. Those are CP642 computers. That's what the NTDS computer was based on. That's a 32-bit, or it might be 30-bit, not 32. I couldn't find a better picture of them. And they were replaced by this one here. This is a XIII computer here. It's called a 4-bay XIII. Each one of those is more powerful than this 642, obviously.
That would have been on a ship.
That would have been on a ship too, right? Now, those were actually on a lot of ships. The XIII was a big computer. I mean, it was a powerful computer, and it was well thought of, very reliable. They use them on submarines. They use them on, again, we're showing terror. They had all the same stuff on Talos and on Tartar ships as well. And that's the UC-43 computer. This computer replaced the UC-7. And you see it looks like it's got 2 halves, top and bottom, but actually each half is a whole entire computer in itself. So it has, it's like a dual computer with, it's like its own backup, if you know what I mean. And each one of them was equivalent to, well, each half of that was equivalent to the 4-bay XIII. And they were using them up until they were decommissioned. Nowadays, they use commercial off-the-shelf computers, which this is, sorry about that. This is the UC-20 computer here. Can you still hear me? Because that's upside down. This is the UC-20 computer, which is a 16-bit computer. It's a small one, maybe that big, you know. And that was replaced by UC-44, which I'll show you next. They would use 2 of these to replace that WDS Mark 11 system I told you about. They also had a thing called SEER-1, which was a communications tracking set. It used that. They had a thing called SIS-2, which used 2 of these. What they did on that was they would, like every radar has errors in it. So like say a 48 radar, maybe it's off by a 1/10 of a degree clockwise, maybe some other radar's off this little bit and that little bit. And they're not linear. It might be off more, say, in the northern quadrant than it is in the southern quadrant. I don't know why that would be. Maybe the ship's structure, refracts the beam or who knows what. So what they did was they would do an alignment where they would track a target with the 55 and then compare it to all the other radars. And they'd build up a map. And that map would be stored in these SIS-2 computers. Then, when the radar displays went out, they would show a corrected display for each radar. No matter what it said, they would all set it just the right amount, so it would be. It was pretty neat, really. And this is the computer that we have, except this is only an 8-channel computer. This is the 1219. So this is available in 2 different styles. Like I said, 16 channels or 8 channels, this being the 8-channel computer. And this would have been used on a Tartar ship. They didn't have as many channels. The Terrier ships all had the dual channel. This is one of the one of the consoles. You can see how the display is just basically a radar display on a scope and she had her hands on the trackball, and over on the left side, those lights where her finger is, that's actually a grid of holes. And you put your finger into the hole, and that would like flick the, like an optical sensor. It could tell that you pushed that button. And those buttons meant different things, like depending on the function of the console. The NTDS program would assign this console a function, and then that function, say it was a track controller or something, well, every button on there would be a certain thing. But if it was being assigned in targets, then it would have a different meaning for each button. Plus, as they operate through, when they push one button, that might change the grid to a whole other pattern to do whatever they're doing now. And the equipment next to it is like, kind of like a transponder on an airliner, where you get the repeat backs from the aircraft and you can tell where they are, what their altitude. And the screen at the top just tells you information about the target that you have connected. This is another one. It's a different console. It's a newer console. But this shows you more about how many there are. They're like crammed in there. This picture here is, I think, about 1980. It's amazing. And this is one of the old consoles. This is called a UIA4. This is one of the very first consoles. You can see it's more analog. Anyway, so that's the end of Johns Hopkins. That's why Johns Hopkins had the computers to be able to give to us, because they did all this development work. Now the boring stuff. Not that the other stuff was interesting. What it was when we first started work, we started thinking about the computers sitting there, Dwayne and I, and we wanted to work on, but we really don't know, what do you have? So we want to get power onto, well, what kind of connector do you need? So we were trying to take pictures of the connectors on the equipment in the warehouse. And this is pretty much just almost like a slideshow. So all this is going to be here. That's more connectors on the back of the I/O console. That's a bad picture. This is just showing in the warehouse. That big cable hanging down the back is actually a special cable that has to be connected to halves of the tape drive. And we were wondering if we had that. And Dwayne asked me, did we have that? So I had to take that picture to tell him that, yeah, we have it. It's another picture of that. So this is the I/O console. It's a 1532. We call it a Mark 77. Well, we proposed to the club management that, how about if we take one of these I/O consoles, because we have 4 of them, and we're going to convert it over to 60 cycle operation, because we didn't have 400 cycle power available to run that. Although we did have a little generator, but we decided we wanted to do 60 cycle. This is a picture of the little generator. This came from Johns Hopkins too. That's not showing the generator yet. That's just the nameplate data. There's the actual generator. Now that's a 1,000 watt, 3-phase, 400 cycle motor generator. But it was wired for Y power, and we needed delta power, so we had to go in there and change that to, well, my pictures aren't in the right sequence. There's another picture from that. This is the top of the computer. That's the power cable for the computer. These pins, I don't know if you're familiar with military connectors, but that connector is available in like 6 different styles, and each one is rotated a different amount so that you can't accidentally plug the wrong pin or the wrong cable into the connector. And you can see how filthy it is too. Of course, it is in the warehouse. There's a better picture where we could actually see the data on the pins, and let us go So anyway, from that data, we were able to go on eBay and order connectors. And we found a guy who had a set of 3 connectors. He had one of the socket like is on the unit and 2 plugs. So we said, well, that was a good deal because we could use one for the computer and use the other one for testing with. And we did. Anyway, I'll go get to that. This is just, again, surveying. We're saying, what do we have? What kind of connect? This is the output of the generator right here. There's a lot of pictures of that. You can notice that one of the plugs has 4 wires and the other only has 3. And of course, I should say 5 on that one because it's got a ground in the center. For some reason, I took a lot of pictures of that. I don't know why. Again, we're just trying to survey. What do we have? And again, we had to buy mating connectors because if we're going to use that generator, we have to have a plug that's going to screw into it. Now, you can't just buy these at Home Depot because they're not NEMA standard. They're called non-NEMA connectors. That's just something they sent us. We don't know what it is really. It's kind of like a gender changer for the different kind of connectors. Now, we use the one on the right. It's a multi-plug connector. These other ones are the kinds of connectors that are used on a UNIVAC 20 and on a UNIVAC 7 computer. So you could connect, if you had like a UNIVAC 7 and a 1219, you could hook them together just by another picture of that. So here we are. This is the power supply pulled out of the 1532 I/O console that we're going to modify. I didn't take very many pictures of this. I don't know why. And this is the 400 hertz transformer and power rectifier assembly that we pulled out. I have that sitting over here on the floor if you want to look at it when you're leaving. It's heavy as can be. So what we did, we bought these Meanwell power supplies from Mauser or Jameco. I'm not sure where we got them. And you can see I have like mounting brackets on the 3 smaller ones. They were meant for a DIN rail, but we didn't know how much room we had. We kind of like just playing it by ear, and we're only here for the 2 days because it was a workshop weekend, so we had to get something done. So I ended up having to take them off because there wasn't room. That picture's not too good. Another one. And we just mounted 3 of the supplies inside. You can see behind it a piece of phenolic board, like regular pegboard. And what we did, we ran tie wraps through the pegboard into the bottoms of the power supplies to hold them in place. There it is wired up. And the power supplies, we decided on the size of the power supplies based on these fuses. What is the fuse rating? If the fuses were, say, 1 amp, you get like say a 2 amp supply. A couple fuses were like 7 amps, so we'd have to get like an 8 amps or a 10 amp supply. And it's just showing some of the wiring. My camera wasn't working so good that day. This is the 27 volt supply that's used to operate the punch, the paper tape punch in the computer. It turns out there wasn't any room in there for that, so we have it on like a long cable. It's like an 18-inch cable. And it works out that when you put this power supply back into the cabinet, it's behind the drawer. There's like a little plenum space this wide, and there's a vent in there. So we were able to just lower this power supply down into that space, like a rope hanging down into it, you know. But that's all we could do. Then we started, anyways, that's another story. This is kind of a little bit out of order. Here we decided we needed to test our 400 cycle generator that we have, the one they gave us. So we're going to build a power supply, or a dummy load for it. Now the dummy load's sitting here on the floor, the finished loads, if you would like to see what it looks like. But we just took a bunch of pictures of it as it went. That's the finished load without the bulbs. The idea was we could put, like, say, 3 bulbs in. This is wired for a 3-phase delta. So we could put 3 bulbs in and have, say, 300 watts, put 6 bulbs in, get 600 watts, you know, or use 60-watt bulbs, use whatever size light bulb you wanted to get the power. And when we used this with all 9 100-watt light bulbs in there, we only had like 108 volts, I think, coming out of the generator at that load. So we just knew that. Anyway, so then we lit off the I/O console, and the first thing it tried to do was run a paper tape through it to see if it would handle the tape. Well, it turns out this is what our capstans look like. There's a few there. they're not good. So anyway, I took too many pictures. There you can see that the pinch roller is all gummed up with that green stuff. It's just everywhere in there. We had to clean all that out. Here's a picture of it after we cleaned it, and the capstan's missing. You see the pinch roller there. So what we did was we took the capstan and sent it out. Well, first of all, we tried to fix it. This hose here is about the right diameter. The inside diameter is just right, and the outside diameter is just almost exactly right. So we cut a small piece of it off and put it on the thing. But it turns out that little bit of curve that you see in the hose was still there on the pinch roller. And it made the pinch roller gap settings to be 7/1000 of an inch. So it worked out that from the one edge to the other, it would be more than 7/1000 of an inch, that curve. So the tape either wouldn't feed, or it would feed forever. It would feed when it wasn't supposed to. So that didn't work out. So we heard about this guy, Terry's Rubber Rollers, and you sent it to him. This is what came back from him. They're really nice. Of course, it's like $80. Yeah, it's not cheap. It's not. Here's a picture of the generator. I think here is where we're getting ready to test it. Again, there's the cover off when we did the wiring change to make it Delta. Another picture of the plug, famous plugs. And you can see how the cable's coming out of the end of the box. That was why we didn't power it up first. We wanted to fix that, so we fixed that. That 3-pin plug we don't really need. There it is, fixed. This is a picture of a 3-phase 400-cycle suicide cord. What happened was we didn't have that connector. We took a lot of pictures of the connector, but we didn't know what it was, and we didn't know where to get it yet. We finally did find it on eBay, but at this particular day when we're doing this test, we didn't have a connector. And we didn't want to go home without testing it, so we just jammed the wires in there. A better picture. A little bit of safety was concerned. We did put shrink around it. Excuse me. I got it off my mouth. And there it is, lit off. So the generator actually did work, which was good. Then what we got here in this picture, we had already gotten the connectors. And you can see that, well, the first connector is the one that fits on top of the computer. The one up here at the back that goes into the outlet, we made a small jumper, like a 2-foot jumper, and left bare wires on it so we could put a clamp on ammeter. We wanted to measure how much current that the computer used while it was running. This is another picture of the same thing. That's the 400-cycle relay that we were worried about in the I/O console. We had to jumper that out. So we can't turn the on-off switch on the console doesn't work. We have to turn it on and off by turning the AC off on the output. This is the paper tape punch in the back of the I/O console. This is the path that follows. There's like a little track to carry the paper out to the front. Now, it turns out that both of the brackets were broken on that, and that was causing a lot of problems. You can see that this one's taped on this one. This is supposed to run, but I can't remember what it's doing. Let's see what it's doing here. Well, all right, what this is doing is it's reading a paper tape in, printing it on the printer, and punching a tape at the same time, coming out the bottom right through that little track that we just saw. So that was kind of our first successes with we actually got it kind of running, you know. These are the books we finally got for that fellow, like the ones that Evan said magically appeared. Well, let me tell you, that was about a 2-year episode getting those books, because we knew the guy had the books. He offered them to us. He kept saying he's going to send them. We're going to send them. We're going to send them, but they never came. And we kept bugging him. And you don't want to bug him so much that he just gets mad at you, because we don't really know. We never actually met the person, you know what I mean? And eventually he succumbed to our emails, and I think he took them all down to like one of those pre-shipping places and had them ship it for him. So that was another expensive deal, but you can't get this stuff. And also, after we got these, what we did was we took and scanned each manual in manually and fed it up to Picasso for his library. Bitsavers. This is a picture of the computer drawer open. That group of 4 cards there that are bound together is the NDRO memory, which is non-destructive readout memory, and that is the bootstrap program for the MagTape drive. We were trying to get the part number of it and just see if we could research it. We never really could find exactly what it was. You can see there's a lot of cards. There's about 2,000 of these cards in the computer. I have some of those cards sitting here on the table if you'd like to see them. This is the main significance to me of this picture is it says it's a type 1219B on this label, and the other label says it's a Mark 152. There's always a question of what is it called. In fire control world, everything is a mark and a mod, and in the regular world, it's different. Let's see what's happening here. This is a picture of the computer. It's not. There's no power or anything on it. Of course, that's the tape drive that we have. We have 2 of those. This is the Mark 75 SDC. This was designed by APL, and then they had it made by somebody else. And this provided all the A to D interface between the UC-20, or excuse me, the computer, the Mark 152 computer, and the missile system, the missiles, the radar, the guns, the whole world that it talked to. We had this on display for a while. This is just some special test equipment that APL made, and all it really is crossbar switches, and it lets you connect one I/O console to any of 4 computers, or vice versa, any of 4 computers to one I/O console. And the bottom half did the MagTape units. Another picture of this. What is this here? Well, it's just showing you how we had to run the tape out the top rather than through that little slot. That way, because it kept jamming up, and when it would jam, then the paper would jam back in the punch. You got to take it apart to fix it. Now the punching hole, it was working, it was punching holes, but it wasn't punching perfect holes. And as a matter of fact, it was missing a couple bits. It turned out that we had 2 missing cards in this unit. So after we found that out, we got the other books, and we got the memory, the maps. We have the chassis maps of each unit. And we compared, we did a 1-by-1 comparison of every card that was installed with what the book said should be there, and verified that it was the right card in the right slot. And none were missing. And none were missing. Just those 2 for some reason. This is showing the output channel bank of, I'm not sure if it's the left or right one, but you can see there's a CE register and a CO register. One's the odd channels, the other's the even channels. And you can see there's 7 channels there. There's channel 0 through, 8 channels, 0 through 7. And those bits are like external function is output data request. It's all basically handshaking. This is the same thing, but for the other, is it or not? No. This is the center one. The upper unit, the upper register there is AU is A upper, and the next one's A lower of the accumulator. Now you notice they have colored rings around each one of those light bulbs. Every third ring is a different color. And that way, it makes it easier to enter your data. We did everything was done in octal. And of course, the program counter is down there. I can't remember what all. Main, you see this main there, that's the timing. Those lights are supposed to be running. And that's the lower half. It has those switches there. There's 5 stop switches and 5 skip switches. There's an actual instruction for each one of those switches to check that switch. Is it on or is it off? And the program would respond depending on what the condition was. A typical use would be like you might have a stop 3 switch, set that up, and then the program would solve that instruction. It would stop, and then you would enter data into the AU and AL register to set parameters for the computer, like tell it what I/O channel you're talking on, how much memory is in the machine, any kind of question that you had to do that that needed to be put in. That's how data was entered. And there's the generator. It's not plugged in yet, but it's ready to be plugged in. We're getting ready here to do the first power application to the computer. Now we knew that this is only a 1,000-watt generator, and we know that the computer wants 1,500 watts. It says 1,500 to 2,000 watts. So what we did was we pulled out both I/O channel chassis, and we pulled all the fuses on the memory chassis, so that only basically the clock and the program counter and that area had power. And there it's set up. We got the ammeter on that little test cable we showed before. That's another picture of the same thing. Now this is the actual first application of power to the computer. I think we can see Bill Iridian's picture reflection in the glass there. He was taking a picture. So you hear the noise. And they got a program power fault up there. And where he's touching those lights, they're supposed to be scanning. That's the clock. It's supposed to be running, and it's not running. So anyway, that's that. It's pretty much dead. Not doing anything. Nothing went boom. No smoke or just that whistle, which is as irritating as all get out. It is ear piercing, I'll tell you. It's more. This is the power cord for the tape drive. The tape drive needs 60 cycle power and 400 cycle power for some reason. I don't know why that. Did I click the right one? Yeah. Well, I don't know why I went to this page, but we decided that Dwayne found a schematic for an RS-232 to UNIVAC interface. So we decided we were going to make one. And this is where we were starting. The trouble is they use a special chip, like a application-specific chip, that changes the voltage levels. The I/O on this is negative 15 volts is 0, and 0 volts is a 1. So we had to have negative 15 volts to convert positive 5 volts to negative 15 volts as a. So that's what we were trying to do there. That scope, you can see it is doing it. We got the 5 volts on the one and 15 volts on the other. So our little interface design worked. Then we start just working again. Here we're trying to make a cable. We draw a little wiring diagram. Wired it up. But anyway, it's still not working. We have that, still not finished. So, but that's something we want to use because we want to be able to load in programs from a PC if we can, because the tape drives and everything are so hard to do anything from. That's just showing one of those special connectors I showed you that was hanging behind the that plastic sheeting in the beginning of this display. And I was just looking at them, they're about P1 and P2, and just logging it. More connectors. I'm a connector man, what can I say? And this is the top of the 1540 tape console. And we're going to, again, before we hooked this up, we did get a vacuum cleaner and vacuum all this out. We didn't get soap and water and wash it down, but we did vacuum it up, and it's relatively clean. It's not spotless. Just trying to identify connectors again. That's the 1540 tape reproducers. Just to, I think there's another picture. If you look at the bottom there, it has N0017. That's the contract number. And the -69 in there is the date of that contract when that was made. So that dates that tape drive as 1969. Again, the top of the tape drive. It's a little bit cleaner here. Not so. Again, the two plugs. I think we were getting ready to put power onto the tape drive for the first time. Matter of fact, their power is on half of it right now. You can see that one green light's lit, the top right. But there's nothing really going on. And here it is with both power lights lit. We were trying to get it where we could work on it, but we ended up having a big problem with this roll of tape. This roll of tape was defective. It's got like the binder that glues the oxide onto the tape. It's kind of like glue, and it really didn't want to advance there. It just kept jamming. This is just showing the path, the way the tape works. It doesn't have real big columns. It uses those arms to store the extra tape. It just winds it back and forth. And inside that little green or olive drab, whatever you want to call it, between the two wheels, that's the vacuum chamber there. And here it is, we just put power on the drive just to see if the arms would center up, and it did. So we were happy with that. That was our first major accomplishment on it didn't run away. It's just a picture. This is the tape. This is the only documentation we have on the tape drive. We're missing all the other books. And we got this from a guy who worked for NASA. Apparently NASA had they use these same tape drives for their like Apollo program, and they use a lot of the same computers that we use. But he went to a school, like a training school, and they gave him this book as a training school, and so he scanned it for us, and he sent us the scan in the mail. And we took it down to Staples and had them print it out. And so this is the only documentation we have on the tape drive. Here, what we're doing is, this is right next to the card printer in the museum. We're measuring to see if the new generator that we're trying to get would fit there. That's the power supply in the room. We were hoping to get three-phase power out of that room. Am I out of time? All right, I'm almost done. Again, a three-phase circuit breaker. See too many of them. These are tapes that Dwayne had in his collection. They're not too much there. They're mostly factory acceptance paper tapes, but they're nice to have, and we were able to run some of those tapes. This is one of the drawers open. You can see all the cards, other drawer. Another connector. Yeah, this is the tape, this is running, I'm not sure what's, on this one is the first time we had, so you see the tapes change, it's got a big hole in the plastic reel. But this one actually moves. So there's what, we're just doing this in manual mode by pushing the forward button, then it will stop. It'll stop. I hit the reverse mode. It'll reverse until it gets to the BOT marker. This uses reflective strips that are mounted on the tape. And there's a little light sensor in the drive. So that proved a little bit to us. But just one of the steps in bringing it back. Yay, we finally got three-phase power. This was important because we wanted to buy this generator from eBay, and they only had like a 2-week time to turn it back in. So if we ordered it and we got it, what are we going to do with it? We have to be able to turn it on to test it. So that was all. This is really important that this get done. That's the fuse that drives it. Then we just I'm making a cart here. The original aluminum generator you saw was on wheels. And we decided that the new one, we would do the same thing, put it on wheels. That way, we don't need to get the building code to inspect it. It's like portable test equipment. We don't have to have, you know what I mean? We don't have to run cables through the wall and have building inspectors come in and do everything. So this Harbor Freight is your friend. We got 4 250, 275-pound casters each. And there it is, made. I put a sheet of phenol on top just to make it look nicer. Now, I only drilled one hole in it because I didn't have a good enough plan to drill all 3 holes. I figured I'll just get one, and then we can center it up later by using the equipment. And there's our new generator. This is a Georator, 5,000 watts. And that's the power that came in on it. We're going to put it over onto that dolly. So me and Evan, we're going to move that. Well, turns out me and Evan aren't strong enough to move that onto there. It weighs about 300 pounds. But there was one guy over there in the warehouse, and he did it by himself. I don't know how he did it. He was younger, that's for sure. So there it is on the dolly. And what we did, we tied like a rope on it and just pulled it like a dolly, a wagon, all through the back of the warehouse, all the way back into the computer museum. It feels like about a half a mile. I don't know how far it really is. So there it is. Now my plan was to just take the generator, plug it into the wall, flip the switch, the circuit breaker, to run the generator. But everybody told me, well, that's not right. And they were right. So we had to buy this motor starting unit right here, just on the left. And it has like a relay in it and protection devices, the on-off switch. We had to buy that separately from eBay. That little other switch we had to buy separately. And that connector, you can see it's got a cable cut off on it. eBay again. That's just showing that one switch being installed inside the motor controller. We're just trying to document the overloads in case one blows out. We know what kind to buy again. Another plug. Again, this one actually has a built-in voltage regulator circuit. So this is what it looks like under the cover. Now it turns out this was not wired for anything. It was just open. So we had a wire for 3-phase delta. Now it turns out that these little jumpers you see on the bottom left of that terminal board, are to program the voltage regulator to know that it's not delta, or whether it's delta or not delta. So we had to set them up. Just a bunch of pictures there, crap. Then here's that plug. We had to take it apart again. We decided we had to get rid of that 3-conductor jack because we want to plug the computer and the tape drive in at the same time. So we needed a new 5-pin plug. And that's what we're doing here. But all this stuff takes time. Like this might take you all afternoon or something just to do this socket, you know? And that's the big plug on the end. That's what plugs into the generator because they wanted us to do it nicely. So there's the generator set up and hooked to this dummy load that's on the floor over here. And there it is lit. Yay! Thank God for that. We measured the voltages. All the voltages were 115, just like they should be, no matter what the load. So that was great. I don't know why I have all these pictures. They just have. Here we tried to put it in a different location. That's just showing the connector that goes on the computer. Here on the floor, you see a bunch of long computer cables. We got those from APL, and we're just measuring. We're trying to get two that were the same length, and were long enough to connect, like from the I/O console all the way to the computer, etc. So we're kind of just sorting cables there. This is power on the tape recorder. You can see it was messed up a little bit, so we had to fix that wire. Here you see the connectors plugged in. Unfortunately, I got them on the wrong channel. I got them on channel 7. They're supposed to be on channel 13, the tape drive. So I moved them. There's the two plugs, both plugged in at the same time. The 3-phase power. And there's the computer turned on, but how it first appeared. And again, those clock lights aren't running up there. You see the ones I showed you previously, below the AU register, there's a row of lights. So it took a better part of a day to find that problem. Here's Dwayne working on the computer. The generator again. We blew a fuse, and of course, in the process of finding a fuse, I lost the cap. So I had to go in the warehouse and get this fuse cap from another system and just documented it so if I ever find it, I know what it looks like. These are the first bad parts we found in the computer. That's a core memory unit, 4K by 18, and a few bad cards. They're all sitting right here on the table as well. Okay. What we got here? I'll go to the very, well, we have to wrap up, I have to wrap up. We were trying to run, maybe this one will show us. We finally ran our memory tests and everything, and we got Hunter Wumpus loaded. So there we go. I happen to have that, I found that in my basement, that tape. I had it from when I worked in the shipyard. I don't know why I had it. But I brought it to VCF East, I think 2 years ago, and Kyle Owen was here at the time, and he had a paper tape copy machine set up. So he copied it for us, and Dwayne took one home with him, and he got it working in his emulator, so we knew that it worked.
So the computer worked really the first time when you got the clock counting?
No, the memory was bad. We had to get the memory fixed. Then later on we had interrupt problems. That's just showing how it is. These are the tapes that we got. They're just showing, you don't see that. This is, I don't know what's going on here. Yeah, oh, I don't want to see that. That's not. There is a video I want you to see, but not that one. See if I have to wrap it up. You see, we moved everything. We put the teletype on the desk instead of on top of the unit. I changed the punch to a different punch. You see where the tape rewinder's on the top left. Well, it turned out not to be good when we relocated the museum because it's like a family slideshow. I can't talk. Well, this was bad. This was a fan that was bad. A fan sitting here. We couldn't. Memory wouldn't run without that fan in there. We couldn't get 10 passes of the test to pass until we replaced that fan. Then it kept memory cool enough where it worked. Yeah, it's working inside. You had to take out that drawer to work on it. That was a big job. It doesn't look like a big job, but it was. I don't know how many. I got too many pictures here. I'll get to the end. Yeah. Well, anyways, this is another. Here we're just testing trying to figure out what was wrong with the paper tape not punching properly, and he was running the computer. I think an op step here. I don't know why it's not running. So it just runs real slow. It's really nothing. There it goes. See how it's going real slow. That's our new punch. Get past this. The internet's acting up. Again, we took the top off, moved the tape winder to the other side. This one here, you could watch this one. This is the computer with a full diagnostic program that we got from the Navy actually running. And I'm going to end it on this because this is good. This is really a hard thing to get to.
Like an ice.
Real, yeah, lots of them. I had pictures of it when it fails too, but but anyway, so we're getting there, and it's a lot of fun working on it. I need Dwayne to help me, and he lives in Virginia, so it's like he can't come as often. Anyway, so that's that.
What's next on your list to do?
Well, we want to work on the tape drive, get the magnetic tape drive working for real. One of Dwayne's buddies gave him a case of tape, brand new case, never used, still sealed. And we also have two head alignment tapes. One sealed, never been opened, and the other one's still there, but it's in good shape. So we have the ability to do the stuff. We don't have the procedures because we don't really have that other book. But we're still working on that.
How many of these exist today?
Well, we don't know. We know that there were originally, I think, 390 of these made. And like each ship, when I showed you that one ship, that would have had 4 of these on that. Every ship like that would have had 4. Then the tail ships, they all had them, and the Tartar ships, they all had them. NASA used them. Yes.
There's one in very, very good condition on the USS Midway in San Diego.
I saw that on TV. I mean, on TV, on the internet. I saw that, and I don't know what condition it's in. Though it's
I don't
really,
know if it's running, but it looks
Yeah.
pristine. I put some pictures up on Facebook for it.
yeah. See, the trouble is, when they take these and give them to you, they take all the core memory out of them because they think it might have secrets in it or something, you know. But anyway, so we managed to get some core memory off of eBay. They were under like $400 for each 4K, and we got a couple from various undisclosed sources.
What's the max memory you can have?
Huh?
What's the max memory?
Well, the way we used it was 32K. The way this one's set up is 32K of 18-bit words. They could make a 64K one, and there's a 40K version also of this computer.
So guys, we have to wrap up, but there's good news. Bill will be here all weekend in the museum. He'll be demoing the computer all weekend, and you can ask Bill questions for hours and hours and hours. So we have to answer them.
Yeah.
We have a full schedule of classes this afternoon. How about a big hand for Bill?
It's just this one last picture, that's where the tape drive is now. It didn't work so good last
I
time.
wrote to him at 8 o'clock. Guys, I just want to tell one quick little story because it's funny. So he told me one of our members donated money for the motor generator we bought. And Bill told me it's, you know, a small thing, it'll be arriving in such and such date. So I got here and an 18-wheeler showed up. I said, Bill, what did you buy? Turns out it was the last delivery of the day, it was 1 pallet. So the computer will be up and running in the Oops. And Bill will use those. And Wayne, who made the emulator, is probably happy to share that if anybody wants to play it on their own time.
Thank you all again for attending.
You did great, Bill. I'm sorry.